Is it visible, sir? Hello.
Yes, sir.
Okay. Good morning, student. Today we are going to see lesson number 14, Substances in Common Use, Part 2. Myself, Ashok Gadge from Shahjinagar BMC English Secondary School, Chitta Camp, Bombay. First, we will go through the first part. In first part, we have seen important salts which are used in day-to-day life. Out of them, first was sodium chloride, that is table salt. Second one, sodium bicarbonate, commonly we called as a baking soda. Third one, sodium carbonate, that is washing soda. And calcium oxychloride, commonly it is called as a bleaching powder. Then we have seen what do you mean by salt. These are the ionic compounds which do not contain H plus or the OH minus ions, and they contain only one kind of cation and anion. These are called as a simple salts. Some of examples we have seen: Na2SO4, K3PO4, CaCl2. In Na2SO4, -2 charge on the SO4 molecule is fulfilled by +1 charge of 2 Na molecules. In K3PO4, -3 charge on PO4 is fulfilled by +1 charge of 3 potassium molecules. And in calcium chloride, +2 charge on calcium is fulfilled by -1 charge of 2 chlorine molecule. Therefore, here there is no H plus ion as well as OH minus ion. Then we have seen what do you mean by acid and what do you mean by base. Acid is the substance which on dissolving give rise to H plus ions as the only cations. Some examples: HCl, H2SO4 and H2CO3. Then we have seen what do you mean by base. A base is the substance which on dissolving give rise to OH minus ions as the only anions. Example: NaOH, CaOH twice. Then we have seen what do you mean by acidic, neutral and basic salt. Acidic salt, the salt is neutral when pH is 7. It is formed from strong acid and strong base. Then we have seen the acidic salt pH value is less than 7. It is formed from strong acid and weak base. And the last one is basic salt. The pH of that salt is more than 7. It is formed from weak acid and the strong base. Then we have seen some crystalline salts. What do you mean by water of crystallization? The water of crystallization means having fixed number of molecules present in one formula of a unit of salt. Some substances, these are the 5 substances. First, alum, borax, Epsom salt, barium chloride, sodium sulfate, and those substances have molecular formula. In that molecular formula, the number of water molecules are considered as water of crystallization. In alum, it is 24 water molecules. Therefore, water of crystallization will be 24. In borax, it is 10. Epsom salt, it is 7. Barium chloride, it is 2. And sodium sulfate, it is 10. Then we have seen what do you mean by soap. Soap is when oil or the animal fat is boiled with aqueous solution of sodium hydroxide or the potassium hydroxide. The sodium or the potassium salt of carboxylic acid are formed, and these salts are called as a soap. So what do you mean by detergent? Detergent is a surfactant or the mixture of surfactant with a cleansing property when in dilute solutions. We have seen the difference between soap and detergent also. Soap are made up of from natural ingredient, whereas Detergent are synthetic and man-made. Soap is sodium or the potassium salt of carboxylic acid, whereas detergent is sodium or potassium salt of long alkyl chain that terminate into sulfonate group. Soap will leave a film, detergent are free rinsing. Soap is uh, hard water is enemy of soap. Detergent can work in any level of water hardness. Commercial soap production utilizes expensive natural resources like vegetable oil, and in detergent typically consumes pure natural resources in the manufacturing process. Now we have seen difference between bathing and washing soap. In bathing soap, high grade fats and oils are used as raw material. In washing soap, low grade fats and oils are used. Expensive perfumes are added in bathing soap, and cheap perfumes are added in washing soap. Bathing soap are potassium salts of long chain fatty acid, whereas washing soap are sodium salt of long chain fatty acid. Bathing soap are usually soft, washing soap are usually hard. Bathing soap is free from alkali to ensure skin injury, whereas washing soap contains some residual alkali. Now, we will move on to the second part of this lesson number 14. In second part, we will going to see what do you mean by radioactive substance, what will be the nature of radiations, and we will see the experiment by Henry Becquerel. Then we will see some chemical substances which we use in day-to-day life. First, radioactive substance. The elements with high atomic number have a property of spontaneously emitting invisible, highly penetrating, and high energy radiations, and this property is known as radioactivity. Some of examples: uranium, thorium, and radium. These substances are having the property of radioactivity, and those substances are called radioactive substances. The nucleus of those radioactive elements is unstable. Radiation continuously occurring from that unstable nucleus. Now, what is the nature of these radioactive substances? In 1889, Rutherford discovered that the radiations emitted by this radium are two types. They are alpha and beta radiation. Villard discovered the third type, namely gamma radiation. Therefore, the radiations are of three types: alpha rays, beta rays, and gamma rays. When these rays allowed to pass through the oppositely charged plates, they are getting separated, and this method is introduced by Rutherford in 1902. We will see in detail, that is the experimental setup. This one is radioactive substance in lead box. To ensure a single ray, the slits are in the way of place in between the path. Electrical plates of positive charge and electrical plates of negative charge are placed. Now, the Rutherford and Villard studied that radiation emitted by radioactive substances. For this purpose, the rays were allowed to pass through the electrical field, which is created by these electrical plates, and a photographic plate was held in their path. Now, what we have observed, it was found that the radiations was divided into three types. One type of radiation deviated towards negatively charged plate. The second type of radiation deviated substantially towards the positively charged. And the third type of radiation do not deviate at all in the electrical field. Now, What will be the conclusion? The rays which deviated slightly towards negatively charged plate are called as alpha rays. The rays which deviate substantially towards positively charged are called as beta rays, and the rays which do not deviate at all are called as gamma rays. Now, introduction to scientist. The French scientist, that is Henri Becquerel, was studying pichabelin, that is the compound of uranium. Now he has done one experiment. In that experiment, he kept some unused photographic plates in the cardboard in the box in his drawer. He placed key on that box and he left uranium compound on that material, and after few days he washed the plates only to find that the plates were cloudy and showed the shape of the key. Now, in this incident, this incident occurred totally in the dark. So Becquerel inferred that the uranium compound might be emitting from their interiors the rays like X-rays which penetrate that substance, and these rays were later called as a Becquerel rays. After a few days, Madame Curie, who discovered similar properties in the radioactive compound, that is thorium. Now this is the another setup. Ernest Rutherford in 1871 to 1937, he was the scientist from New Zealand, did research on radioactivity under the guidance of J.J. Thomson and Cadwish at the Cadwish laboratory at Cambridge and McGill University, Canada. He showed that the nitrogen atom could be split by bombarding it with alpha particles. And this experiment ushered in a new era of the field of physics. Now we will see the characteristic of alpha, beta, and the gamma rays. In the first column, we can see the property. Second, alpha rays, beta rays, and gamma rays. Nature of alpha ray is current of alpha particle, current of beta particle is current on alpha particle is positive, on beta particle it is negative, and gamma rays, these are electromagnetic radiation. Mass, almost gamma rays have no mass, beta rays have some mass, and alpha rays are having maximum mass in if compared in three of us. Next, charge +2 charge on alpha rays, -1 charge on beta rays, and gamma rays are electrically neutral. The velocity of alpha rays are 1/5 to 1/20 times the velocity of light. Beta rays have velocity 1/5 to 9/10 times the velocity of light, and the gamma rays, these are the fastest rays, same as the velocity of the light. Next, deviation in the electric field. Alpha rays attract toward negatively charged, beta rays attract toward positively charged, and gamma rays do not deviate. Penetrating power. Alpha rays have they can penetrate an aluminum sheet more than 0.02 millimeter thickness. Beta rays can penetrate through 2 mm thickness of aluminum sheet. Gamma rays, they can penetrate 15 centimeter thick lead screen, which is 10,000 times the larger than the alpha particle. Ionization power. Alpha rays have very high ionization power. Beta rays have very low ionization power. and gamma rays have very low ionization power. Power of production of fluorescence. Alpha rays have very high power, beta rays very low power, and gamma rays have low uh, power of producing fluorescence. Now, next concept, that is isotopes. What do you mean by isotope? These are the atoms with same atomic number but different atomic mass number are called as a isotope. What do you mean by isobars? The atoms with same atomic number, same atomic mass number but different atomic number. And what do you mean by isomers? These are the compounds with same molecular formula but different structure are called as a isomers. So first we will see what do you mean by isotopes. Here is the example of carbon. Atomic number of carbon is 6. Therefore, carbon atomic number is 6, which is same, but atomic mass number is different. So it is called as a C12 and C13. These both are isotopes. Here are some example: hydrogen, carbon, oxygen, chlorine, potassium, and uranium. So these are some isotopes. Next, isobars having same atomic mass number. Argon having atomic mass number of 40, potassium atomic mass number 40, calcium atomic mass number 40, but they are having different atomic number. Argon is having 18, potassium 19, and calcium is 20. So here are some examples. Now, what do you mean by isomers? These are the compounds having same molecular formula, but they are differing in their structures. So here, butane is their structure of butane and butane 2-ene, butene is same. Uh, Molecular formula is same, but the structure is different. So number of carbon atom 1, 2, 3, 4. 1, 2, 3, 4. Number of carbon atoms are same, but their structure is different in different forms. Therefore, they are called as isomers. Next, radioactive isotopes. We have seen isotopes. Now we will see what do you mean by radioactive isotopes. These are the isotopes of an atom that emits radiation. So why radioactive substance only emits radiation? The radioactive substance emit ionizing radiations as their atom undergo radioactive decay. So radioactive decay is the emission of energy in the form of ionizing radiation. Now, what are the uses of isotopes? There is a misconception that radioactive isotopes are only used in making atomic bombs. So radioactive isotopes are also useful in scientific research, agriculture, industry, medicine. Radioactive isotopes are also used in radiation alone as for the research, and it can be used in radioactive element also. Now we will see natural radioactivity. Here is the diagram of modern periodic table, and radioactive substances are shown here. These are having high atomic number. Uh, Generally, these elements with atomic number 82 to 92 are found to radiate spontaneously in nature, and they are called as a natural radioactive element. Now, artificial radioactive elements. The couple Frederick Juliet Curie and Erin Juliet Curie first introduced radioactivity. The radioactive substances produced in the nuclear fission process brought about in laboratory by bombardment of particles called artificial radioactive elements. They were awarded Nobel Prize in 1935 for this invention. Now, radioactive isotopes are used in various fields. First, industrial field for radiography, measurement of thickness, density, and level, luminescent paint, radioluminescence, and in ceramic articles also. Next field is agricultural field for production, increasing productivity, food preservation, tracer for research in various crops, and the third field is medical field for the disease like polycythemia, bone cancer, hyperthyroidism, and tumor detection and treatment also. Now we see in the detail. First, industrial field, radiography, the internal cracks and voids in the cast iron articles, and iron soliders can be detected with the help of gamma rays. For this purpose, isotopes like cobalt 60, iridium 192 are used in the radiography camera, and this technique is used for detecting flaws in the metal. Next one, for measurement of thickness, density, and level. It is necessary to maintain the required thickness in particular uh, aluminum, plastic, iron sheets of different thickness. In the manufacturing process, radioactive substances placed on one side, and from the another side, it is detected. The radiation read by the measuring instrument varies with the thickness of the sheet. The material inside a packing can also be examined with the same technique also. Luminescent paint and radioluminescence, the radioactive substance like the radium, promethium, tritium with some phosphor are used to make certain objects which are visible in dark also. So one of the best example is clock in your hand which will glow in dark also, and certain other objects. Krypton 85 is used in HID, that is high intensity discharge lamp, while promethium 147 is used in portable X-ray unit as the source of beta rays. Next use is in ceramic articles. The luminescence color are used to decorate ceramic tiles, utensils, and plates. Earlier, uranium oxide was used for this paint. Now, the second field is agricultural field. The genes and chromosomes that give rise to seeds property like fast growth, higher productivity, etc., can be modified by means of radiation. The radioactive isotopes, cobalt 60 is used for food preservation. Onions, potatoes, these are irradiated with gamma rays from cobalt 60 to prevent their sprouting. Strontium 90 is used as a tracer in research on various crops. Next field is medical science. The disease polycythemia is the disease of red blood cell. The red blood cell count increases in this disease. Phosphorus 32 is used for this treatment. Bone cancer, strontium 89, strontium 90, samarium 153, and radium 223 are used for the treatment of bone cancer. Hyperthyroidism, the enlargement of thyroid gland, weight loss in spite of appetite, insomnia are some of the symptoms of hyperthyroidism. It occurs due to overproduction of hormones by thyroid gland. Iodine 123 is the best treatment for hyperthyroidism. Tumor detection, boron 10, iodine 131, cobalt 60. These are used for the treatment of bone tumor. Arsenic 74 is used for detection of small tumors in the body. Now, what are the drawbacks, or we can say hazards for radioactive substance and radiations? First, the most affected system is central nervous system, which is affected by radiations. Hereditary defects, which are generated by bombardment of radiation on DNA in the body. Radioactive radiations can penetrate skin, causing disease like skin cancer, leukemia. The radioactive pollutants created due to explosion either enter the body through air and it is difficult to control them. Fifth one, the radioactive pollutants released in the sea enter the bodies of fish through them. It is entering in our body. The radioactive paint on the watch can cause cancer. The radioactive isotope strontium 90 can enter our body through plant, fruits, flowers, cereals, milk also, and causes disease like bone cancer, leukemia. Now, one of the disaster which occurred in Chernobyl factory on 26 April 1986, the graphite reactor in Chernobyl atomic power plant exploded and suddenly the radioactive isotopes and radiation come out. Due to this episode, radioactive isotopes enter the human body through water and land, and it is causing genetic disorders also. These got carried further into next generation. Thyroid disorders increase in children as well as in adults. As a result, the incidence of throat disease is greater than the other places. Some chemical substances which we use in day-to-day life. The following things affect our health directly or indirectly. Number one, the food that we eat and the object like clothes, utensils, watches, medicines, and other objects which are made from various kinds of matter. These two things are affecting our health directly or indirectly. Now, first, the sweet shop looks attractive because the colorful sweets which are displayed there. Which colors are used in this substance? So answer is it is edible colors. Now these edible colors are called as a food colors and essence. These food colors are mixed in the most of the soft drinks and food stuff available in the market. These food colors are in the form of powder, gel, and paste. Food colors are also used in domestic as well as commercial products. Certain food colors and essence are added to ice cream, ice candy, juice, fruit juice, cold drink, pickle, jam, jelly. Food colors are often found to be added to packaged meat like chicken and mutton. Chili powder also, turmeric, sweets, and other similar substances to give them a good and attractive color. Now, what are the harmful effects of artificial food colors? First, the food colors added to pickle jam sauce, they are containing small quantity of lead and mercury. These can be harmful for those who consume on a regular basis. Disease like ADHD, attention deficit hyperreactivity disorder, can affect children due to excessive consumption of food with uh, added food color. Now, uses of natural food color is always good. First, food colors are natural as well as artificial. Food colors prepared from seeds, beetroots, flowers, and fruits concentrate as the natural. Tetragen, sunset yellow are the artificial food colors which are extensively used. However, overconsumption of artificial food color can be detrimental to health. Therefore, usage of natural food color is always good. Now, we will go through some question answers. First, dash is used in the treatment of hyperthyroidism. Answer, iodine 123 is used for the treatment of hyperthyroidism. What is meant by radioactivity? Answer, the property of spontaneous emitting invisible, high penetrating and high energy radiation of elements with high atomic number is called as a radioactivity. Examples, uranium, thorium and radium. Next question. When the radiation coming from the certain radioactive substance is passed through that electrical field, marks are found at three places on that photographic plate. Answer, the radiation coming out from radioactive substance fall on the photographic plate. When photographic plate is developed, three distinct spots are observed on the plate. This shows that the radiations are split into three parts in the presence of electric field. Now these radiations are deflected first towards the negative plate. These are called as alpha rays. Towards positive plate, these are called as a beta rays. And towards they are not deflected by electrical field. They are called as a gamma rays. Now, uses of radioactive substances. First, industrial field, agricultural field, and the third one is medical field. Now, in industrial field, in radiography, it is used for detecting internal cracks and voids in the cast iron articles and iron solders. For this purpose, isotopes like cobalt 60, iridium 192 are used in the radiography camera. This technique is also used for detecting flaws in the metalwork. Luminescent paint and radioluminescent. Radioactive substances like radium, promethium, tritium with some phosphor are used for certain colors which are visible in dark. Krypton 85 is used in HID, that is high intensity discharge lamp, while promethium, that is 147, is used in portable X-ray camera. It is also used for measurement of thickness, density, and level also. It is necessary to maintain a required thickness in the manufacturing of iron, aluminum, plastic, and iron sheet, which are having different thickness. In this manufacturing process, the radioactive substance is placed on one side and that instrument is placed on another side. Now, when radiations are passing, the radiation read by the measuring instrument, it will vary with the thickness of that particular sheet. Also, material inside the packing can also be determined or examined by same technique. Also, these radioactive substances are used in ceramic articles. Luminescence colors are used to decorate ceramic tiles, utensils, plates. Earlier, uranium oxide was used for this paint. Now, in the field of agriculture, the genes and chromosomes that give seeds properties like fast growth, higher productivity can be modified by means of radiation. For that purpose, cobalt 60 is used. Onions, potatoes are eradicated by cobalt 60 for preventing the sprouting. Strontium 90 is used as a tracer element in the research of various crops. Now, in the medical science, polycythemia, it is the disease of red blood cell. When red blood cell count increases in disease like polycythemia, the phosphorus 32 is used for this purpose. Bone cancer, strontium 89, strontium 90, samarium 153, radium 223 are used for the treatment of bone cancer. Hyperthyroidism, enlargement of thyroid gland, weight loss in spite of appetite, insomnia are some of the symptoms of hyperthyroidism. It occurs due to overproduction of hormones by thyroid gland. Iodine 123 is used in the treatment of hyperthyroidism. And the last one, that is tumor detection, boron 10, iodine 131, cobalt 60. These are used in the treatment of brain tumor. Arsenic 74 is used in the detection of small tumors in the body. Thank you.